would be 1, 1 equals 2, and 2, 2 equals 5. What is our first thing we need? A 1 in row 1, column 1. And it's there. So then we have to get zeros for everything else in column 1. So I have to turn this into a 0. Since it is a 2, we are changing row 2, so row 2 equals row 2. It's positive 2, so we subtract 2 of row 1. Okay. So row 1 doesn't change. So 2 minus 2 is 0. 2 minus 2 is 0. 5 minus 4 is 1. Okay, stop right here. Next we want a 1 in row 1, column 1. But you'll notice if you're trying to get a 1 here, you have to just add row 1 and it undoes your 0 work, doesn't it? If you ever have zeros on the whole left-hand side, we need to stop and think what this means. This says that second equation is saying 0 equals 1. But it doesn't. So what does that mean? No solution, inconsistent. So we can still pick up on those inconsistent systems using this method. If you ever get all zeros equal a number, you know right then you can stop and tell me there's no solution. Alright, so that was kind of rude of me, I guess. Tricked you on the first one I gave you to do on your own. Okay, let's do one together and then I may give you a nicer one to do on your own. Okay. Do you notice anything odd about this one? I have 3 variables and only 2 equations. So let's see what happens. So my x is 2, y is -5, z is 3, equals 1. 1, -2, -2 equals 8. Alright, we want a 1 in row 1, column 1. So how can I do that?
Row 1 equals row 1 minus 2 row 2.
Okay. You could, if we're trying to get a 1, you could just do row 1 minus row 2, if you're wanting a 1. So,
You can like flip them.
or you could flip the 2 rows, since we have a 1 below it. We haven't flipped any rows yet. You want to do that just for practice? What I usually do if I'm flipping rows, I just say row 1 equals row 2. And then all you have to do is flip. Now there were multiple ways to get that. You could have done row 1 minus row 2 and got a 1. You could have done row 1 times a half and got a 1. Or in this case, we were also able to just flip. So lots of options available to us. Okay, next I need my 0. So that's currently a 2. In order to get a 0, I am changing row 2. So row 2 equals row 2. It's a positive 2, so we will subtract 2 of row 1. So 2 minus 2 is 0. -5 minus 2 times -2. That'd be -5 plus 4, so -1. 3 minus 2 times -2. So that would be 3 plus 4, so 7. 1 minus 2 times 8. So 1 minus 16 is -50. Now what? We have to get this to be 1. What's the easiest way to do that? Okay, so row 2 equals row 2 times negative 1. So 0 times negative 1 is 0, negative 1 times negative 1 is 1, negative 7 and positive 15. Next, if we're finishing column 2, we need this to be a 0. So I'm changing row 1, so row 1 equals row 1. It's a negative 2, so we will add 2 of row 2. So row 2 isn't changing. One plus 2 times 0 is 1. Negative 2 plus 2 is 0. Negative 2 plus negative 14 is negative 16. 8 plus 30 is 38. Does everybody understand how I'm getting my numbers? All right. It's good, but I have a problem. Do I have a row 3, column 3? No. If I stopped and wrote my equations right now, I have x minus 16z equals 38. And this one will be y minus 7z equals 15. If you have more variables than you do equations, this is going to be one where there are infinite solutions. You're going to have to write it with something arbitrary. Remember when we did those before? We usually wrote it with y arbitrary. Which variable do you think we should keep arbitrary right here? Z. They both have a z in them. So we could very easily solve this for x. X would be 38 plus 16z. Y would be 15 plus 7z. So my answer, I have my x, comma, y, comma, and my z just stays as z. So if you have more variables than equations, your answer is going to look something like this. There are going to be infinite solutions, so you will have something arbitrary. All right, any questions there? What did you guys do a problem? I'll go back and I'll give you guys a nice one this time. See how far we got. So our matrix should be 1, 1 equals 8, 1, negative 1 equals 4. You want a 1 in row 1, column 1, and we have it. So next we want a 0. Anytime you're trying to get a 0, you can follow this method. Put the row you're changing, so row 2 equals row 2. It is a positive 1, so I have to subtract 1, but you can't just subtract a constant. It has to be a multiple of another row. So I have to do 1 times row 1, or just row 2 minus row 1. So row 1 doesn't change. 1 minus 1 is 0. Negative 1 minus 1 is negative 2. 4 minus 8 is negative 4. Next, we go to row 2, column 2, and I need a 1. Easiest option, if you're looking for like a pattern that you could do every single time, anytime you want a 1, you can just multiply by the reciprocal, and that will always give it to you. So row 2 equals row 2 times the reciprocal would be negative 1/2. So row 1 didn't change. 0 times anything is still 0. Negative 2 times negative 1/2 is 1. Negative 4 times negative 1/2 is All right. Next, we are working on column 2. We have my 1, so we need a 0 right here. So to get a 0, we are changing row 1. So row 1 equals row 1. It is a positive 1, so we need to subtract 1 of row 2. So row 2 isn't changing. 1 minus 0 is 1. 1 minus 1, 0. 8 minus 2 is 6. So our solutions, we have x equals 6, y equals 2. So it's the order pair 6, 2. If you were doing this on your homework and you want to know if you got the right answer, what would you do? Other than raise your hand and ask me if you got the right answer. Yeah, plug it in. 6 plus 2 equals 8. 6 minus 2 equals 4. It works. Okay. I know there is a huge learning curve on these. Like, it takes a while to get to that point. Once we're there, they become much easier, but it does take a while to get the hang of it. How did you guys do on that one? Okay. Do we want to try one with 3 variables? Do you want to do it together? I'll give you a few minutes to start it on your own then. We'll go over it, and if you guys feel okay at that point, then I might give you some time to work on homework. It's not going to be a very long assignment today. So the first thing we need is a 1 in row 1, column 1. And there are a ton of ways to get that on this problem. You could take row 1 times a half. You could flip rows 1 and 2. You could do row 1 minus row 2. You could do, replace row 1 with row 3 minus row 1. There are a lot of different ways. What did you guys do? Flip? Okay. And if you didn't do it this way, don't start erasing. You're fine. Okay, so I have my 1. I need both of these to be zeros. We can do this in one matrix. If you did it in multiple steps, that's okay. So row 2 is a positive 2, so we're going to do row 2 minus 2 times the row that has a 1 there, so 2 of row 1. Row 3, started out, it's row 3, it's positive 3, so subtract 3 of row 1. So row 1 didn't change. 2 minus 2 is 0. 2 minus 2 is 0. 0 minus 2 is negative 2. 6 minus 2 is 4. 3 minus 3 is 0. 4 minus 3 is 1. All right, guys, I'm not going to talk over you. Negative 1 minus 3 is negative 4. 13 minus 3 is 10. What'd you do here? Okay. There are multiple options, but the easiest option, if you have one with a 1, then go ahead and flip them. Row 2 equals row 3. I've got my 1. I have one of my zeros. I need to make this one a 0. So we are working on row 1. So row 1 equals row 1. It's a positive 1, so subtract 1 of, which row has a 1 in it? Row 2. Yeah. So 1 minus 0 is 1. 1 minus 1 is 0. 1 minus negative 4 is 5. 1 minus 10 is negative 9. Alright, we're 2/3 of the way there. Last row, or last column, excuse me. Row 3, column 3. I need a 1 here. What would be the best option to get that? Row 3 times the reciprocal, negative 1/2. So it's 0, 0, 1, negative 2. Alright, we need zeros everywhere else in that column, so we're going to do both of those in one final matrix. So row 1 equals row 1. It's positive 5, so I subtract 5 of row 3. Row 2 equals row 2. It's negative 4, so we add 4 of row 3. Okay, so 1 minus 0 is still 1. 0 minus 0 is still 0. 5 minus 1 is 0. Negative 9 minus 5 times negative 2. So negative 9 plus 10 is 1. 0 plus 0 is 0. 1 plus 0 is 1. Negative 4 plus 4 is 0. 10 plus negative 8 is 2. So we have x equals 1, y equals 2, z equals negative 2. All right, here is what we are going to do. I've taught you all the content, but we are going to spend several more days practicing this stuff. But I am going to go ahead and give you an assignment today. And I do want you to open up your books. I want to talk about something on one of those. So turn to page 518. Problems 2 and 4. All they are asking you to do is a row operation to change the matrix. But they didn't necessarily tell you which row to replace, so I want to see if we can read that and see if we can figure out which row they want to replace. So like number 2 says 7 times row 1 added to row 2. So which row do you think you're replacing? Row 2. So you're changing your row 2 on problem number 2. On problem number 4, negative 6 times row 3 added to row 1. So which row are you changing in problem 4? Row 1. Alright, so this assignment is actually not very long. The first 2 problems are only row operations. Problem number 8, you are just writing a matrix. You're not solving it, just writing the matrix. Problem 12, you're just writing the system of equations. The only 2 you are actually solving are 18 and 22. Both of those just have 2 variables, so you should only have to solve 2 matrix problems. And you've got 15 or 16 minutes to work on that right now.